Next, we're going to discuss present value, PV. Calculation of present value answer to questions such as how much do I have to invest today to have some amount in the future. If we rearrange the PV and FV relationship formula in the previous page, we're going to get this PV is going to equal to FV divided by 1 plus R to the power of T. This R here is the interest rate. This T here is the time period, is the periods. This periods could be yearly, could be quarterly. If it's quarterly, then say the periods, the duration is 4 years, and if this interest is compounded quarterly, then you're gonna use 4 year times each year has 4 quarter, right? 4 quarter. So in total, it's gonna be 16 periods. Interest rate, following the same logic, it's gonna be the periodic interest. So suppose we know the yearly interest rate is 16%. That's the yearly interest rate. Okay. Then the quarterly interest rate is gonna be 16% divided by 4. It's gonna be 4%. Therefore, this 16 periods is gonna be the T here, and the 4% is gonna be the R here. So when this T and R, when we talk about T and R, they need to match. If you're talking about periodically, if you're talking about quarterly compounding, then both R and T need to be in the quarter format. If we are talking about yearly compounding, then both R and T need to be in the year format. They need to match. Okay, they need to be consistent. Okay, a lot of times students make mistakes by input R as yearly interest rate, but T as quarterly periods. You're not matching them. They are not consistent. Therefore, you get a wrong answer. Okay. So here we say PV is gonna equal to FV divided by 1 plus R to the power of T. Okay, that's basically this formula is telling you. Okay, in finance, when we talk about discounting, we mean finding the present value of some future amounts. Okay, that's the meaning of discounting. We're gonna see several examples. PV example 1. Suppose you need $10,000 in 1 year for the down payment of a new car, which is the case if you're in college. You will need some down payment for a new car. If you can earn 7% annually, how much do you need to invest today? Okay, this is a question. Again, we can do it using the financial calculator. We can also use Excel to solve this question. In reality, in your future daily work, you're gonna use Excel much more often than the calculator. Let's now try to use Excel. So you open the Excel. Okay, you open the Excel. Then we're gonna put all the elements in this function. So we are given that's future value FV. Okay, FV, and we're gonna have M periods, right? We're gonna have I interest rate. We're gonna have payment. PMT represent payments, and we are interested to figure out PV, present value. Okay, present value. Now we know the future value you need to have. That's your cash inflow is $10,000. Just put positive 10,000. You put positive number there. That's represent the cash inflow or cash outflow. Okay. Here you put a positive number there. That means this is a cash inflow. Okay. M periods. How long is the periods? 5 years. 5 years later you need the money. So N equal to 5, right? I interest rate. How much you're gonna earn? 7%. So you put 7% there. Pay attention. It's not 7. It's gonna be 7%. Okay. In your financial calculator, you're gonna put 7 there. You ignore the percentage sign. But here in Excel, you use this 7% because Excel is not a pre-programmed. Programmed. This financial calculator is programmed. Yeah. Okay. So in financial calculator, you can put just 7 there. Payment. How much? nothing, right? No additional payment during the period, so you put 0 there. Present value, then we're gonna use a function that Excel provides to you, PV. Okay, you put PV there. Now you put PV, you choose PV, then it gives you a list of elements that you need to input to calculate the PV. Rate is 7%. You just select 7% here, then put a comma. Periods 5. Put another comma. Okay, payments, select 0. Okay, put another comma. Future value 10,000, right? Is it 10,000? Yes, 10,000. Just select that one. Okay, put comma. Type, as we said earlier, this future value, present value, normally the default value is 0. We are going to differentiate the difference between 0 and 1 when we talk about annuity. Here, we're going to choose the default value 0, which means this cash flow occurs at the end of the period. So we select 0. Okay, then put the parenthesis. Now this function is finished. This function is finished. If you press enter, it's gonna pop you up the result of present value. Let's press enter. So it's a negative number. You see the number is in red. In red means this number is a negative number, and it's in parentheses. In accounting, in Excel, if a number is in parentheses, that means it's a negative number. And here in our scenario, this number is in parentheses. That means this is a cash outflow. This is a negative number. This is a cash outflow. Okay, it's a cash outflow. Periods. Okay, here the periods for the down payment. If you earn, how much do you need to invest in 1 year? I'm sorry, this is not period. Is not in 5 year. Periods here is in 1 year actually, right? It's in 1 year. So it's in 1 year. So we input a wrong number there. So we need to change M to 1, right? It's actually 1, not 5. So that's, you see how convenient the Excel is. If you have one thing wrong, you don't need to start over to do it again. You just change the thing that's wrong, change the element that has the wrong input information. Then everything else will change automatically. That's the smart thing about Excel. So you change it to 1. Now your present value is $9,345.79. That's exactly what we show here. Okay, it's exactly what we show here. Okay, right? Okay. Next example, you want to begin saving for your daughter's college education, and you estimate that she will need $150,000 in 17 years. Okay, $150 in 17 years. That's around $40,000 a year. $40,000 a year. Suppose we don't consider inflation. $40,000 a year, is it enough to cover the tuition? Is it enough to cover the college education nowadays? I don't know. You guys are college students. You tell me. So $40,000. I think probably for public university, public college, that's probably enough. You have the tuition, probably 15,000, 20,000, 15,000 a year, and then you have the living expense. Probably that's enough. But if you go to private college, a lot of private colleges, tuition itself is like $40,000. Some of those big name colleges are even more expensive, or even higher than $40,000. So it's not gonna be enough. But suppose this is $140,000 is saved, need to be redeemed 17 years later when your daughter become 18. Okay, if you feel confident that you can earn 8% per year, which is pretty high, 8% per year. The CD, the deposit rate is not as high as 8%. Okay, how much do you need to invest today? How much? Okay, again, this is a cash flow question, and it's about present value. How much you need to deposit today? Okay, so we're gonna open our Excel. All right, open our Excel. So let's open our Excel. Future value, how much is it? Future value is how much? you need 150,000, right? 150. It looks like 150,000. Okay, it's the money that you need to get in 17 years. You can put it as positive number, or you can put it as negative number. It doesn't matter. If you put a negative number here, then later on when you calculate your present value, that's gonna be a negative number. Okay. If you put a negative number here, later on when you calculate present value, your present value is gonna be a positive number. So here we suppose we put a positive number here, means 17 years later we do want to get $150,000 to pay for the daughter's tuition. Okay, periods, how many years? 17 years, right? 17 years. 17 years. Okay, interest rates is 8%. Okay, put 8% there. We put 8%. Payments, it's 0. Okay, payment is 0. And present value, okay, we need to, here you need to input the PV function again. PV. Okay, you need to put equal and then put PV. Then you select PV. That's one way to do it. Excel has another smarter way to do it. You can, if you just drag it. Okay, drag this. When this sign here become a plus sign, you see, if you click this cell, it's a bigger plus sign. Then when you move to the right corner, this sign become a plus sign, become smaller plus sign. So if you drag it to the right hand side, this formula will be applied automatically, okay, to the other two cells. See, here there is no input here, so it's 0. It's 0. So let's delete this. It's 0. So let's see the row that we're interested to know. So here you see it's 40,000 negative number, $40,000 negative number. If you double click this cell, you will see the functions. So this function is applied automatically, following the one that we use in the previous cell. So this one we don't need it. We just delete it. Okay. So here the number, the answer is 40,000, 40,540, and 34 cents. That's exactly what we do. We get it here. That's our answer. So this means now we need to invest $40,540.34 in order to get my daughter's tuition 17 years later. Okay, that's the answer. We can conclude two important relationships about present value. By the way, those Excel skills, the one that I showed you here, are just the basic Excel skills that you're gonna use in accounting. But it's very, very useful functions and useful techniques. That's it is the most important skill when you have a financial analyst job or as accountant job. Okay. We can conclude two important relationships about present value. For a given interest rate, the longer the time period, the lower the present value. Does that make sense? Yes, that makes sense. What's the present value of $500 to be received in 5 years? 10 years, the discount rate is 10%. Say, if the period is 5 years, okay, then we put the T as 5. If the period is 10 years, then we put the period as 10. The other things, this is a future value, doesn't change. Future value, they are 500. The interest rate 1.1. This is a discount factor, right? It's coming from 1 plus 5%. I'm sorry, 1 plus 10%. 1 plus 10%. This is also 1 plus 10%. 1 plus 10%. If you plug in those numbers into this formula, you will figure out the present value for 5 years is around $300. The present value for 10 years is around $100. Therefore, you see, this is consistent with our conclusion here. The longer the time period, the lower the present value, right? The longer the time period, the lower the present value. This one is 100, is lower than the $300. Okay, so the longer the periods, the lower the present value for a given interest rates. Next, for a given time period, the higher the interest rates, the smaller the present value. The smaller the present value. That makes sense if you go to see the formula PV equal to FV divided by 1 plus R to the power of T. We say for a given period, time is given. Time is a constant number. The higher the interest rates, the higher the R, the lower, the smaller the present value. That makes sense. The higher the R, the bigger of this denominator. Okay, the bigger of this denominator, suppose FV does not change, it's a constant number. The bigger the denominator, the smaller the present value. The smaller the present value. If we use the numbers to illustrate this conclusion, we're gonna get the same answer as we show in this theoretical concepts. We're gonna talk about it in the next page. This is page 3.